Okay, so in today's class we will start learning about Fourier series. Okay, so we will try to cover up the concepts of Fourier series, then we will solve some of the problems. So first of all, I am following the book by Professor Erwin Kreszik. The book name is Engineering Mathematics 10th edition, written by Professor Erwin Kreszik. So first of all, I will upload this book, no problem. Okay, so first of all we should know that what is Fourier series. So Fourier series are infinite series that represent periodic functions in terms of cosines and sines. As such, Fourier series are of greatest importance to the engineer and applied mathematician. To define Fourier series, we first need some background material. So what are those background material? So first of all, we should know that what is meant by saying periodic function. Okay, a function fx is called periodic function if fx is defined for all real x except possibly at some points, and if there is some positive number p called the period of p f such that f of x plus p equal to fx. Now I am giving one example like fx equal to tan x. This fx equal to tan x, this is not a periodic function and is not, as it is not defined, fx equal to tan x, this is a periodic function and is not defined for all real x but undefined for some of the points. Okay, such as tan x is not defined at x equal to plus minus pi by 2, x equal to plus minus 3 pi by 2, etc. So the graph of a periodic function has the characteristic that it can be obtained by periodic repetition of its graph in any interval of length p. That means you can consider the portion from this peak to that peak, and if you repetitively put this peak to this peak, that part from here, you will get the actual graph. Similarly, you can take length about any of length p. You can take like this length p, or from this length p, or from this length to that length p. So that is how you can actually determine periodicity. This p is the periodicity, length p. Now the smallest of such p, the smallest positive period, is often called the fundamental period. Okay, so familiar periodic functions are the cosine function, sine function, tangent function and cotangent function. I am just showing you some of the graphs of the these functions for your convenience. See, y equal to sine x. So y equal to sine x, this is a periodic function having periodicity 2 pi. See, up to this is 2 pi. You repeatedly put 2 pi, you will get repetitively the this graph itself. Simply y equal to cos x. It is also a periodic function with periodicity once again 2 pi. Y equal to tan x. Y equal to tan x. This green. So you can see that it is also a periodic function having periodicity 2 pi. Okay. Y equal to cosec x. Oh, sorry. Y equal to 1 by sin x. So this is the graph of y equal to sin x. This is the graph equal to 1 equal to sin x, so cosec x. So also you can check that this cosec x is also a periodic function. You just repeatedly copy these two sections, you put them consecutively, you will get this cosec x function, right? Similarly you can plot sec x or cotangent x, etc. Now you may also ask that are there exist non-periodic functions or aperiodic functions? Yes, of course, there are exist aperiodic functions such as x, x square, x cube, e to power x. So we observe that y equal to sin x is periodic, right? But y equal to sin hyperbolic x, it is not periodic. You can check it that y equal to sin hyperbolic x is not periodic. So all these functions 1, cos x, sin x, cos 2x, sin 2x, cos nx, sin nx, these all functions have periodicity 2 pi, and they forms the so-called trigonometric functions. So this is cos x, this is cos 2x, this is cos 3x, this is sin x, this is sin 2x, and this is sin 3x. Now, so the series which contains a series that contains elements like this: a0 plus a1x plus b1x plus a2x cos 2x plus b2 sin 2x plus and so on, which can be written explicit in a more compact way, that this equals to a0 plus n equal to 1 to infinity an cos nx plus bn sin nx. a0, a1, b1, a2, b2 are constants. These are called the coefficients of the series. We see that for that each term has the period 2 pi. Hence, if the coefficients are such that the series converges, its sum will be a function having periodicity 2 pi. Now, so suppose fx is a given function of periodicity 2 pi and is such that it can be represented by a series 4, that is 4 converges and moreover has the sum fx, then using the equality sign we can write fx equals to a0 plus and so on n equal to 1 to infinity an cos nx plus bn sin nx, and call this 5 as the Fourier series of fx. We shall prove that in this case the coefficients of 5 are the so-called Fourier coefficients, and that are given by the Euler formulas. So a function fx that has periodicity 2 pi, that can be written in this way. Okay, so the Fourier, the Euler formulas, these are actually given by the Euler formulas. Okay, So just remember these things, that a function fx, a function fx, if fx can be written like a0 plus this type of thing, then this fx can be expressible, or this a0 a and bn, that can be written in terms of 1 by 2 pi minus pi to pi fx dx, 1 by pi minus pi to pi fx cos nx dx, and 1 by pi minus pi to pi fx sin nx dx. Now we will determine a very basic example of like very basic example, a function. So that function is given as minus k if minus pi less than or equal to x less than or equal to 0, and k if 0 less than x less than or equal to pi. So this is actually a periodic function with periodicity 2 pi. Functions of this kind occur as external forces acting on mechanical systems, electromotive forces such as in electric circuits. Now if you since it is an odd function, the first a0 coefficient will be 0. ठीक है? Why? Now a1 a2 an, you just remember the formula. The formula for this minus k will be fx is given by two expressions, the integrals from minus pi to pi, split it into two integrals. So minus pi to pi fx cos nx, so first break it as minus pi to 0 minus k cos nx, 0 to pi k cos nx, and then you integrate it from minus pi to 0, then this will be like, that will vanish, so that will be like 0. And also now the bn part, fx equal to sin nx, so similarly break it into two parts, like minus k and k. For minus pi to 0, like minus k, that will be n will be divided, so k cos nx by n minus pi to 0 minus k cos nx by n 0 to pi. Then also cos is a even function, that means cos minus alpha is cos alpha, and cos 0 equal to 1, which is that this as cos 0 minus cos n pi minus cos n pi plus cos 0, that means 2 is you can take common and you can get it as 1 minus cos n pi. Now there is one recurrent relation. What is the recurrent relation? The recurrent relation is 1 minus cos n pi. So cos n pi is for odd n, cos n pi is minus 1, for even n cos n pi is 1. So 1 minus cos n pi is 2 for odd n and 0 for even n. Simply just putting it here, okay. So hence the Fourier coefficients bn of this function are 4k by pi and b2 equal to 0, b3 equal to 4k by 3 pi, then b4 equals to once again 0, and b5 equal to 4k by 5 pi. So since all ans are 0, the Fourier series of fx are like that: 4k by pi sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x plus and so on. Now you can also use another thing, that if you put x instead of x, you put pi by 2, then f of pi by 2 is equal to k. It implies that, because why f of pi by 2 equal to k? Because from the definition, if x belongs to 0 to pi, then f of x is equal to k. So pi by 2 belongs to 0 to pi, so f of pi by 2 equal to k, and from here on you get 4k by pi into 1 minus 1 by 3 plus 1 by 5 minus and so on plus. So you get the series of 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus minus this is this. This series actually converges to the irrational number pi by 4. So 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus and so on, this is equals to pi by 4. and this is the famous series that was actually obtained by the great mathematician Leibniz in 1673 from geometric consideration. Okay, so like first of all there is some relation which we should remember, right? So what are the relations? The relations are minus pi to pi cos nx cos mx equals to 0, sin nx sin mx equals to 0, sin nx cos mx is equals to 0. It does not matter that whether n not equals to m or n equal to m. Okay, now I will upload the notes, but this is not that much important for you people. So we will only solve particular selective mathematical problems. Okay, so like we will try to determine the Fourier series of, like, say mod x. We will try. Okay, so we will try to determine the Fourier series of fx equal to mod x. We know the formula or the to determine the an. Okay, so just give a minute. So we will try to determine the Fourier series of fx equal to modulus of x. Okay, so I am just stopping this screen share. Is it visible? Now it will be visible. Okay, so our function is our function is fx equal to modulus of x. Okay, you consider that okay, and it has the period 2 pi, right? It has the period 2 pi. So we want to write mod x in terms of a0 plus n equal to 1 to infinity an cos nx plus bn sin nx in this way. Now first we need to determine a0. So what are the formula? It is 1 by 2 pi. It will be minus pi to pi, then mod x dx. Now since mod x is a even function, so that's why the integral vanishes. Now we need to determine an. So what is the formula of an? Can you remember? The formula of an is fx cos nx dx, right? So that will be 1 by pi integration minus pi to pi mod x cos nx dx. Now once again, this modulus of cos x and cos nx, both of them are even functions, so their product is also even, so this integral also vanishes. Now this bn 1 by pi, this is minus pi to pi modulus of x, मैंने कुछ गड़बड़ी तो नहीं कर दिया? No, yeah, sorry, I made a mistake here. Like, okay, I think I made some mistake. Let's follow the conventional way. I made in a bit mistake here. So that is 1 by 2 pi. You break the integral into two parts, minus pi to 0, then it becomes minus x dx, okay. So this is minus x dx plus integration 0 to pi, this becomes x dx. So what does it implies? It implies 1 by 2 pi, that as minus x square by 2 minus pi to 0 plus x square by 2 0 to pi. So that implies 1 by 2 pi, oh sorry 1 by 2 pi so that becomes pi square by 2 plus pi square by 2, so that becomes 1 by 2 pi into pi square, so a0 becomes pi. Now we need to determine an equal to 1 by pi integration minus pi to pi fx cos nx dx. Now our fx is modulus of x, this is cos nx dx. Now once again, this is 1 by pi mod x cos nx. So since it is an even function, you can write it as 2 to pi 0 to pi mod x cos nx dx, or 1 by pi into 2 integration 0 to pi x cos nx dx. Now how to solve this? Is mod cos nx dx. How to solve this? That how to do? Kothandam sir, can you tell me how to solve? We have to use here chain rule. So that becomes minus x sin nx by n integration 0 to pi minus, that will be plus integration 0 to pi sin nx by n dx. that is 2 by pi, and this thing vanishes. This is 0 because sin n pi 0. So sorry, this is 0. So sin nx, this above term, this term vanishes. Okay, so now how we can write it? We can write it as minus, sorry, so that as cos nx by n square. This is 0 to pi. I am wrote now. So what does it implies? It implies 2 by pi n square 1 minus cos n pi. And also now this thing is easy for bn. Bn is 1 by pi integration minus pi to pi modulus of x sin nx dx. Now this is odd function, and for odd function this integration will be 0, right? So what is our Fourier expansion? This will be only Fourier cosine series an cos nx. So what was a0 we obtained? A0 we obtained pi. So a0 we have obtained pi, and an we have obtained 2 by pi n square, n equal to 1 to infinity 2 by pi n square 2 by pi n square 1 minus cos n pi cos nx. Now once again, this 1 by cos n pi, this 1 by cos n pi, this 1 by cos n pi, if n equal to, if what is the value of cos pi? 1 by cos n, cos n pi is minus 1 ki power n. Okay, cos n pi is minus 1 ki power n cos nx. So what does it means? For n equal to, say, you can write it in reverse way. So this thing, this in between thing, that will exist only if n is an odd function, right? So for this you can like keep it like that, you can keep it like that, but also you can write it as you can keep it like that, like n equal to 1 to infinity 2 by pi 2m plus 1 whole square, that will be, sorry, that will be 4. So that is 4 by 2m pi into 2m plus 1 whole square into cos into cos 2m plus 1x. So So we can actually check the answer. I hope that I did not made some mistake. This modulus of x, I hope that I did not any mistake. 6 to 10 modulus of x 482, question number 6. Oh. Okay, the answer is not given, but still we can check. Fourier series of mod x. Okay, I think that you can itself check. I have solved it, so you can check. You can check it on your own, that whether I did some mistake or not. Kotranam sir, is it okay what I did? Okay. Okay, right?
You are uploading this.
हाँ?
Are you uploading this one, sir?
बता क्या क्या बोल रहे हैं आप?
That's the problem solving session.
हाँ?
You are uploading this one.
Yes.
Are you uploading this one?
This video. This video, sir. This video I will upload. No problem.
PDF form.
Okay, PDF I will try to upload. Okay, I will try to upload. Okay, so I think the question number 13, their answer is given. Question number 13. We will solve question number 13, page 482. Okay, A27. So okay. Question number 32 we will try to solve. No. 482. Okay. Okay, 13 is modulus of sin x. Modulus of sin x, the answer is given there. We will try to solve for modulus of sin x, okay, so that we can cross check. So once again, our here I will try, this is our answer. Okay, so is my screen visible? Stop sharing. Share screen. Okay. My screen is not visible. Is my screen, iPad screen visible? just give me leave call. It got stuck, sorry a bit, it got stuck. Sorry, I will try to join it once again. Is my screen visible, Krishnaswamy sir? Hello? Is my screen visible, Krishnaswamy sir? Okay. Now we will try to determine Fourier series of fx equal to modulus of sin x. Here we will try to determine the Fourier series of fx equal to modulus of sin x. Okay. Now how to solve it? And the interval is same, that is 0, this. So first we need to determine a0. What is a0? 1 by 2 pi integration minus pi to pi mod sin x into dx. How to determine this? Next, now how to solve this? How to solve this? Oh, now how to solve this? 1 by 2 pi modulus of sin x dx. Okay, now we need to integrate it. Now how to solve it? So you need to integrate it 1 by 2 pi. This is once again even function 0 to pi sin x dx. This is cos pi is minus 1, cos 0 is 0, so that becomes minus 2 by pi. Next, an 1 by pi minus pi to pi now this is like once again modulus of sin x integration cos nx dx. Now you always remember that Fourier series of even function will be cosine series and Fourier series of odd function will be sine series. This is 2 by pi integration 0 to pi sin x now sin x into cos nx. Okay, I am on the right track. Now you need to use here one trick, that 2 sin a cos b equal to 1 by pi integration 0 to pi sin of n plus 1 into x minus plus sin of sin a cos b sin of 1 minus x dx. Now we integrate it. Okay, so 2 sin a cos b. Okay, so this become integration minus cos of n plus 1 divided by n plus 1 into x minus cos of it will be plus 1 minus nx by 1 minus n to pi, so that becomes 1 by pi next minus cos n plus 1 pi by n plus 1 plus cos 1 minus n pi 1 minus n and plus 1 by n plus 1 minus 1 by 1 minus n. Now this cos n plus 1 pi, this is equal to 1 by pi minus of minus 1 की power n plus 1 by n plus 1, and this is equal to plus minus 1 की power 1 minus n 1 minus n plus 1 by n plus 1 minus 1 by 1 minus n. तो गलत कर रहा हूँ मैं, लग रहा है 482 हाँ मैं गलत का आंसर देख रहा हूँ, मॉड्यूलस ऑफ साइन एक्स। ठीक है चलो, सो मॉड्यूलस ऑफ साइन एक्स, मॉड्यूलस ऑफ साइन एक्स का ऐसे आपको कंटिन्यूअसली निकालना पड़ेगा, ठीक है। ओके, आई एम राइटिंग वन मोर प्रॉब्लम। 15টা কি আছে आंसर? ওকে 15-17টা आंसर আছে। Next we will try to determine question number 15. क्वेश्चन नंबर 15 है Fourier series of x square. Fourier series of x square 0 less than x less than 2 pi. कैसे निकालना होगा? फर्स्ट यू नीड टू डिटरमाइन a0 1/2 pi इंटीग्रेशन माइनस पाई टू पाई x square dx 1/pi इंटीग्रेशन 0 to pi x square dx. This is equal to x cube by 3 pi integration 0 to pi. This becomes pi square by 3. Next an 1/pi integration minus pi to pi x square cos nx dx 1/pi x square cos nx dx. Once again even function into 2 integration 0 to pi x square cos nx dx. So that becomes 2/pi. You apply chain rule minus x square sin nx by n integration 0 to pi. So that will vanish. Next plus integration 0 to x sin nx by n dx 4/pi n square integration 0 to pi x sin nx. Once again chain rule minus x by cos nx by n integration 0 to pi plus integration 0 to pi 1/n cos nx dx. This become 4/pi n square minus pi cos n pi minus pi cos n pi by n plus 1 by this will become minus 1 by n sin nx n square. This is 0 to pi. Now this term will also vanish. So minus pi cos n pi by n minus pi cos n pi by n minus cos pi n by n 4/pi n cube. It becomes this pi cancels. So what we get 4/n cube minus 1 की power n plus 1 because cos n pi equal to minus 1 की power n. So this minus multiplied it gets minus 1 की power n plus 1 and this bn coefficients. This is simply pi minus pi to pi x square sin nx dx. They are 0. So the series becomes x square what we got a0? We got a0 as pi square by 3. a0 as pi square by 3 plus n equal to 1 to infinity 4 by n cube minus 1 की power n plus 1 cos n x 4 by n cube. So this is the answer. Pi square by 3, n equals to 1 to infinity 4 by n cube minus 1 की power n plus 1 cos n x. You can write some of the terms like pi square by 3 plus four cos x minus 1 by 2 cos 2x plus 4 by 27 cos 3x plus and so on. Here did I any mistake? Okay, here is one mistakes that I did mistake, sorry, correct it bit. That will not be, that will be simply, here I did bit mistake. Please be careful, I always do sometime mistake, so be careful. Okay, by n, that will be n, that will be simply n, that will be 4 by n square, it will be 4 by n square. So you can get 4 by 0 cos 2x, then now it is correct. Okay, so the answer is pi square by 3 plus n equals to 1 to infinity 4 by n square minus 1 की power n plus 1 cos nx. Okay, next we will solve, we will try to solve 17 4 6 482. Next we will solve this 17. Can you tell me that what is the actually expression of this function? Can you tell me that what is the expression of this function? Okay, okay, let's move to question number 19. Question number 19. Okay, what is question number 19? Question number 19 is, see, for up to minus pi to 0 it is 0 and then it is increment is 1, then it is increment is 1, this then it is x. Okay, So next we will move to fx equals to 0 for minus pi less than x less than 0, then it is x for 0 less than x less than pi. Okay, next we will try to solve this problem. First we will need to determine 0. So 0 and is 1 by 2 pi integration minus pi to pi fx dx. This becomes 1 by 2 pi. Krishna Swami sir, are you with me? Okay, it's 1 by pi integration 0 to pi is x dx. This becomes pi by 4. Next an. So that will be first chain rule. This vanishes. This next we will determine Pn. Okay, this is 0, you can check. This becomes minus cosine pi by n. So the Fourier series becomes pi by 4 plus an की जगह 1 by pi n square, 1 by pi n square 1 minus cos n pi cos n x plus minus n equal to 1 to infinity minus cos n pi by n sin n x, or you can write it as pi by 4 plus n equal to 1 to infinity 1 by pi n square 1 minus 1 की power n cos n x plus n equals to 1 to infinity minus 1 की power n into n sin n x. So you can determine a1 is 1 by pi to 1 plus 1, that means 2 pi. A2 is 1 by pi, 1 by 4 pi, 1 minus 1, it is 0. Simply you can determine b1 as minus 1, b2 as 1 by 2. So this function fx, the first few terms of the series you can write as pi by 4 plus 2 by pi cos x plus and so on, plus minus sin x plus sin 2x by 2 plus and so on. This is 1 minus oh sorry, यहाँ पे I did a once again I did some mistake. Here it will be plus. I did some mistake. Please be careful while doing this type of things. Don't do this type of mistakes, okay? Don't do this type of mistakes. Be very much careful. Okay, so there will be this is plus, this is minus 1 minus cosine pi, this is minus 1 plus cosine pi. Now it is correct, minus 2 by pi cos. So I made a mistake here, okay? I am just discussing once again this problem. So fx equals to 0 for minus pi less than x less than 0, x for 0 less than or equal to x less than pi. So you get 1 by 2 pi minus pi to pi fx dx, 1 by 2 pi minus pi 0 to pi x dx. So the a0 is pi by 4. Now you just proceed in the similar way. You will get an is 1 by pi n square minus 1 plus cos n pi, and this bn will be minus cos n pi by n. You put it in the form, you will get minus 1 plus cos n pi by pi n square cos n x plus n equals to 1 to infinity minus cos n pi by n into sin n x. And this is how you need to solve it, okay? Krishna Swami sir, any question up to this? Okay, so nobody with me. This problem, can you tell me what is this problem? This problem is also 21, is also very interesting problem. I am defining a problem function for you, a problem for you as fx equals to minus x minus pi, minus x minus pi. And this as pi minus x. If you put x equals to 0, you will get minus pi. You put x equal to minus pi, you will get y equal to 0. This is the function pi minus x. Okay, so for so I am giving this function as an exercise. Okay, 0. Sorry. So I am giving one this you can at least try to do this problem. Minus x minus pi. This mostly excluded this. Minus x minus pi. Oh, I think I'll put minus x minus pi. X minus pi. Okay, so this is our function up to this up to this function. So you need to solve this problem. So what you have to do, you have to just determine, be very careful while solving this type of problems, because there are very much chances that you will make some mistake. So don't do mistake while solving this type of functions. Okay, don't do any silly mistake or you are doomed. Okay, so first you need to determine a0. a0 is 1 by 2 pi minus pi to 0 minus x minus pi dx plus integration 0 to pi minus x dx 1 by 2 pi. This is coming out as minus x square by 2 minus pi x pi from 0 plus pi x minus x square by 2 0 to pi. So here you will get 0 minus pi square by 2 plus pi square. Plus pi square minus pi square by 2, so that will give you 0. देखते हैं इसका क्या आंसर है. 397. There should not exist a0 term. Yes, a0 term नहीं है. तो a0 टर्म आपका नहीं है. So also you can prove that an also 0. You can prove. Next bn you need to determine. If you try to determine bn minus pi to pi fx sin nx dx. So once again you need to break this part, minus pi to 0, minus x minus pi sin nx plus 0 to pi minus x sin nx dx. So only you need to write it will be 1 by pi, that will be minus x sin x by n that will be x cos n x by n plus pi cos n x by n. This value is minus pi to 0 plus now you need to write down the whichever is the answers. So first you put for 0 1 by pi, so the first term is vanishing, 0 pi cos, so that becomes pi by n. This becomes pi by n. This becomes minus plus pi by n minus pi cos n pi by n minus pi cos n pi by n plus minus pi cos n pi by n. Now once again plus minus pi cos n pi by n plus pi cos n pi by n plus pi by n. So these they all vanish, so that becomes, this becomes 1 by pi into 2 pi by n, so that becomes 2 by n. So what is our answer? Our answer is this fx, this is sigma n equal to 1 by n 2 by n sin nx. This means 2 sin x plus sin. This is the answer. So this is the answer. So this was the function. This is the function, and we have determined the Fourier expansion, series expansion of this function. Okay. So thank you. Okay, so we have solved this one. Now we will try to, okay, now आप आंसर को थोड़ा क्रॉस चेक कर लीजिए. आंसर को क्रॉस चेक कर लीजिए. हाँ, आ गया 2 इंटू साइन एक्स प्लस हाफ साइन 2x प्लस 1/3 साइन 3x प्लस 1/4 साइन 4x प्लस 1/5 साइन 3x. तो हमने डिटरमाइन कर दिया है. ओके, so thank you for joining. If nobody is there, so bye.